Good evening, students. I'm really sorry. I was stuck in rain. That's why it took some time. Thank you for waiting. Thank you very much.
Good evening, students. Let's start our session. How many? Eight students are available. Okay, let's start our session right now. Sharing my screen. Is my voice clear? Audible? Is everything clear? Please respond.
Yes, sir.
Thank you. Okay, I'm sharing my screen. So, okay, so how are you all? So, hope you got good time to 2 days of time to practice. Hope you have completed that. So, any feedback from the previous part? Do you have any issues with that, or you are all good with that? Only the difficult thing in that was the creation of the sketch, right? So that was new to you, but with the help of the video, I think you would have learned that. So let me know if you have any questions on that, or if you have any issues faced, or if you have any doubts. Okay, we'll discuss on that first before going to before going to start a new part, designing a new part or modeling a new part. Let's discuss first about that, and then we'll go ahead with that. Yeah. How was your experience, students? I think I'll show you the part also. This was the part, right? So I'm talking about this part. So did you practice this? Any issues in this? Because in last session it got crashed suddenly. The session, so we stopped it after completing this profile actually. But it was completed. Okay. Only thing was the last operation, pad operation, or the stiffener operation, that was left over, and before that, that was crashed. So any issues, you can message me. If you don't want to tell, you can just tell, message me whoever completed your model, or if you want me to repeat this. If you have any questions, if you want me to repeat same creation of this sketch and all what we saw in the last session. If you want to see it again, I'm ready to take a quick session on that. Okay, before going to the new part. So, what's your choice? It's your choice. Okay. So what you want? Shall I start with a new part, or you want me to uh, just refresh this what we did in the last session, and then go to the new part? Okay, please decide and tell me in 2-3 minutes. Guys, all good? Shall I proceed with the new one today? Okay, so let's have a look at this new part. Okay, is it visible? If yes, please have a look. Just study this. Take 2 minutes and study this. Okay, we'll model this part today. Okay, so let's have a look at this skinfully. So what is the direction? Okay, what is the direction of view? That means which view we can take consider as front view, and what is the axis system we can take, how we can take axis system, and where we can consider the origin. Okay, and how to, in which direction it should be extruded, the pad creation, extrusion in the means the pad creation, how we can create it. Okay, and which direction. We have three holes in this part. Okay, and how to create these three holes, and also a cutout at the bottom of this part. Have you observed that there is a cutout of 6 mm at the bottom of this part? Okay, so how to achieve that cutout, and what is the manufacturing process of this part again? Okay, these are the questions. Please have a look at this, just study that, and look at all the dimensions, whether all the dimensions are given, all the features can be created with the given dimensions, or any dimension is missing. Okay, so that also you have to see. If you attend an interview, then they will give you such kind of drawings. Sometimes such kind of drawings, sometimes the drawings which are already created, generated, the front view side, the top view, side view, and the section views. Okay, so such kind of drawings will be given to you. You need to study it first and plan it how to do it, and then you have to start it. Okay, in this planning, what all things included? So all these things which we discuss in our every session we are discussing. So these are the planning. You cannot start this without planning. Okay, so without having answers for all these questions, like which is my front view, which is my top view. Okay, which is my origin, which is my axis system, where I have to place the axis, and why should I place that axis. Okay, in the same place. Why not in some other place? It's okay. You should have answers for those things. Okay, when you finish the model, once you finish the model, then they are going to check and ask you why you placed this here, why you followed this process. Okay, what is the reason behind this? Why did you follow this? Why didn't you follow this? So you should have all this information with you. Okay, so that's why it takes some time. Just go through this and let me know if something is missing. Okay, if something is missing beforehand, you have to inform them, sir, this is not available, so this diameter of this hole is missing, so please provide me the diameter of the hole, or else I can't create it. Okay, it's not possible to create the hole, or sir, depth of or the thickness of the pad is missing. Okay, so such kind of information you have to search for. And if everything is clear, nothing to worry. You can proceed as per your plan. Okay. So what is your plan for this part? You can, as I said, you can reply me in any language. Okay. No English, no Hindi, no Telugu. Any language is okay for me. Or else you can message me. So what is the front view? How you decide front view in this? We discussed already about these things. Basic the basic things which we need to consider first. Okay. Okay. So 98 mm front view. Which one is the 98 mm? Okay. So you mean to say 70 plus 14 plus 14? Okay. Okay. Good. Good. Good, Balaji. That's correct. So this can be because simple because the arrow direction is given here. Okay. If this is not visible, then we have to go for the plan B. What is plan B? The next point is the view where maximum details are available, where you can see maximum details. That should be considered as the front view. Okay. But here you can see simply they have given the arrow, and you need to agree with the arrow also, because you can see maximum details in this area. From this direction, if you see, you can find maximum details, even if you can disagree with them if maximum details are not given. Okay. But if that is their importance of the part, okay, in that case we have to agree with them, because maybe the orientation of the part, where the part, what is the functionality of the part, and how it is sitting in the assembly. So this part is not alone, right? So this part is going to be placed in some assembly where it's going to have some functionality. So based on the functionality also, there will be some change. Okay. So change in the orientation, change in the basic rules. Maybe what we discussed are the basic rules. If you're working on a project, particularly project, then they would have defined some rules for that. See this part, if this is of this kind of part should be considered this as a front view. Okay. Those, there will be so many rules on that, but as of now for us, this is the front view. Why it is? Because arrow direction is given, number one. That is one confirmation. And the second confirmation is you can see maximum details. You can find maximum dimensions from this view. Okay, isn't it? You can see the cutout details, you can see the pad thickness details, you can see the again you have some rib kind of thing at the center rib. Okay, so you can see the 14 thickness of that, that also you can see. Okay, so this many things you can find from this. So the width of the part and the length of the part, that also can be seen from this area. So, so decided, that is front view is this X direction. The arrow direction which they have given, that is the front view. That we have decided. Done. Okay, what is the second thing we need to decide? What is the second important thing we need to decide? So if this is the front view, then this this profile we are going to create on the default plane. What is the default plane what we are using nowadays? That is YZ plane. Okay, Catia default, if you see there. So this we are going to use it today. So this one, what is this? YZ plane. So let's go here and see. This is the front view. Okay, what is default plane? It is showing YZ plane. Okay, let's consider YZ plane. Okay, that is decided. So here maybe let's insert access system here. Okay, guys, directly here also you can insert. Have you seen that? the insert axis system. Okay, that also we can see. So as of now, standard. Okay, right-handed. Okay, as of now, standard we have taken. Okay, these are axis system. If you want to increase the size, let's increase a little bit. Okay, the size I think will be a little bit good if you increase it. So meanwhile, please decide on this where we need to consider the origin. Okay, let me quickly increase the size of this. Infrastructure, part infrastructure, and then display. Let's have it, okay. So now it is increased. Okay, good. Now, guys, I need answer for this quickly. So where we are considering the origin now, and why we are considering origin there. What's your basic idea? I want to know that. Any answer? You can reply me. You can message me, or you can tell me in Hindi, Telugu, English, whatever language you want. Guys, waiting for your reply.
Sir, that 14 mm wall, sir.
Sorry?
The 14 mm wall with that big circle of radius 21, sir. From the front view, we can take.
Radius 21, yeah?
Yeah.
Okay.
So from this front view, we can take that as an origin, sir, which is hidden backside.
Okay, you mean to say this here we can take as origin, okay?
But from this side, sir, from the front view,
From
which
this
will be hidden, sir.
From this side at this height, huh?
Yes, yes,
This is
sir.
the point, okay? This is the point you mean.
Yes,
Right?
sir. Yes, sir.
Okay. Okay, good. Thanks for responding. That's good. And any other replies? Any other answers on this, please? That's good answer. I got 2 messages. Let me have a look. Good. Same answer. One more answer from Balaji also. Okay, Balaji, good. Any other answers? Okay, guys, good. So, as per our discussion, as per the basic details available with us, okay, these are the only things what we can consider, isn't it? So these are the things we can consider as the important things. The one thing is the direction, view, that's decided, and the origin point. Why we have considered origin here? So the two guys who replied for this. So can you also tell me the reason why you have considered it? Balaji and sorry, one more guy. I missed your name.
Sir, circle we can take at right side view, sir. From right side view
Exactly.
as origin.
We can take this as right side view.
Yes,
Side
sir.
view we can take, but why we have decided this?
It will be easy to draw circle, sir. And from front view, we will draw this 90 degrees. No, sorry, 90 mm pad.
Okay, that's one answer. Okay, thanks for your answer. And someone else can answer it, please. One
So
more
because it
answer.
is the center of that design, sir.
Center of that.
Center of the design system, sir.
Okay,
Is
center of the
the
design session.
drawing, sir.
Okay.
Yeah, center of the drawing.
Okay, center of the drawing. Okay, good. One more answer. Share your opinions. Good. Nothing wrong. See, there is nothing wrong, nothing right in this world. Okay, we need to learn. We need to learn, and then we will learn right things. We will approach towards addition, right addition. Okay, unless we try, our effort is required. Okay, put your efforts and try to reply, and share what you are thinking inside. Okay, in your mind what you are thinking. So unless it comes out, we cannot correct it. Okay, so let's try it. Okay, good. Today you people are responding very good. I'm very happy for that. One more answer please. I'm waiting for one more reply.
Sir, can we take the midpoint of the front view as origin?
Midpoint of the front view, let me understand. Okay, so this is
Yeah,
the front view. Okay, so front view is decided. Okay, we have decided
Yeah.
the front view, and
I got it, sir.
you are saying about the midpoint of the
Exactly.
midpoint of the front view.
No, the bottom line, the 98 mm line, midpoint of that
Uh,
48.
you mean to say this
Yeah, exactly.
line? Okay,
Yes.
okay, that is one option. Okay, okay, that is one option. Okay, good idea. This is also good idea. Okay, one more answer please. Any other answer? Okay, guys, very good. So well tried. So almost things are okay. So what we discussed in previous classes, like deciding the origin, means that means you are deciding the, it's kind of deciding the datums. Maybe you are not aware of the datums theory. Okay, datum a datum, primary, tertiary, okay, secondary, tertiary datums will be decided to uh, for a particular part to arrest the complete freedom of the part. Okay, so if you want to machine it, or if some welding should be done or some holes should be done, so we need to arrest it completely. Okay, and dimensioning will be done from that particular part. Okay, particular position. Okay, here why it plays a major role or important role is like deciding a point is very important, because from there we have to consider remaining all the dimensions of the part. And why it is important to decide the point where from where it should be, the dimension should be measured. So it can be measured from anywhere, right? So we need to minimize the differences in the dimensions, or the tolerances, to minimize the tolerances, because you know that no part is manufactured with high precision. Forget about 100% precision. With 99% precision, or at least 90% precision, if you are manufacturing it, then it will be very, very expensive, because the methodology, the process you manufacture the part with the precision tools is very, very expensive. Okay, so that's the reason. So when you are manufacturing a part, for example, when you are in this part, which uh, this this will be your which hole or which part will be your important uh, location. Okay, that means which feature will be done with precision, and why, that we have to see. In this part we are considering that, for example, someone said we can say, take a dimension from here also. Okay, from this part. Okay, maybe because we don't know how this part is going and sitting in the subassembly. Okay, and if this area is very important, and if they are going to manufacture this area with precision, okay, if they are controlling this surface, okay, in that case we also can consider this as datum A, okay, important surface. In basic language, let us say important surface where deviation will be very less, okay. So as of now, in this part, what will be the functionality of this part, this hole? Let us think, okay. So this functionality of this will be like another shaft is going to sit here, okay, and that shaft will be a horizontal shaft. That means this hole, first thing is hole, and this hole, another shaft is going to be assembled in that. That's the reason they are going to control the precision of this hole, okay. Normally the holes means definitely there will be uh, tolerance, tight tolerance for that, okay, to avoid the what we can say, the functionality, misfunctionality of the hole. If the in this hole, if some shaft is coming and sitting, if it is loose, then the whole functionality is going to fail, okay. So they have to manufacture it with great precision. With in this part, this part will be, this hole will be manufactured with great precision. That is what we assume, we are assuming, okay. And if you see these two holes, the other two holes, maybe these two holes are for attaching this part, okay, onto the subassembly, okay. These two parts, maybe some fasteners are coming and sitting inside, okay. Maybe some bolts and screws and nuts will be used to assemble this, so fix this onto the assembly, sub-assembly, okay. And some functionality is going to happen here, okay. Something is going to happen here. That means more concentration on this location. So the position of this hole is important. That means height is important, and at the same time, how much overall, if you see the position means, if you take a small circle here, if they say plus or minus, it should be the center of the hole, should be the center of the axis, should be plus or minus, deviation should be plus or minus zero point 0.1, then they are going to manufacture it in plus or minus 0.1 only. So with that great precision, they have to do it, okay. So we cannot say this is the great precision. We have some other tools where the for example, the uh, small things which they are manufacturing, okay. uh, Maybe for healthcare devices, you can see they will be with great precision, but these things are not of great precision. But still we can say in this part, compared to the other features, this whole is controlled with some value. Maybe that's the reason, if you consider this portion, and if you start measuring, if you want to cut this, if you want to locate this hole, if you are locating this hole from this location, then the difference in the deviation in the dimension will be less. That is the idea behind, or the whole idea behind considering this origin point, okay. Guys, is that clear? I tried to explain in very simple words, okay. If this part is manufactured with precision, that means with very controlled tolerance, then when you measure it from here to here, maybe if you want to, if you are controlling this face, okay. So this, if something is coming and sitting here, then the surface roughness of this face also will be controlled, okay. The surface roughness, okay. And if this part is vertical, then again this portion, this complete feature, vertical, how vertical it is, that also will be controlled. If some part is sitting there, if that functionality should happen properly, if then everything should be controlled, okay. You cannot manufacture it with at an angle, okay. So there will be control over this vertical, how it is 90 degrees, it should be 90 degrees with this surface, horizontal surface. Okay, so that will be controlled and the surface will be controlled. Okay, and a shaft is coming and sitting here. That's the reason inside this hole, this completely axis will be controlled. It will be in exactly plus or minus zero point 0.1. If that is the limit given, then that limit should be maintained. Okay, or else quality department is going to reject it after manufacture. Okay, they are going to check it with the precision tools. They are going to do quality check, and then they will check it. Hey, what is the diameter of this? It's increasing. It is deviating from the diameter what is given, what is expected. It is just plus or minus zero point 0.1 or zero point 0.2. Then just throw it away. So that's completely a waste. Okay, nothing. Designing in Catia, manufacturing it in plant, and the material and the engineer efforts, and the plant person who worked on that, his efforts, everything gone in vain. Okay, so that will happen. Okay, so that's the reason. So they consider a point which is very important, because from there if you take dimensions, that dimension you are going to get with minimum deviation. So for example, if this face is controlled, okay, if you consider this face and this face, if you dimension it from here to here, this is as of now, it is in theoretically it is 42 mm. Okay, and for example, if it is 42 plus or minus zero point 0.2, okay, in that case, if this face is not controlled in within zero point 0.2, then that point zero point 0.2, or if it is zero point 0.3, okay, 42 plus or minus zero point 0.3, this will become, okay, this will become 42.3. You got it? If this face is not controlled, okay, if you measure it from here with the physical instrument, with the scale, if you are, or with a tape you are measuring it from this surface to here, or with some good measuring instrument, if you measure it, because you already deviated here, so what dimension you will get, that point 3 will be get added here, and that point 0.3 will get added, and this will get extended. That means this will become 42.3. Or if it is not controlled at all, okay, if this is a big issue, then this will be 42.5 maybe. We don't know, because the surface is not at all controlled. Okay, if this that's the reason we consider this hole will be uh, manufactured. It should be manufactured with the given tolerances. Okay, yes, definitely it should be maintained. That tolerance should be maintained. If it is not maintained, that those dimensions are going to reflect in other parts of this part. Okay, for example, if this is not maintained, okay, 42.5 it will become, because you have deviated 5 mm here. If this surface is 5 mm this side manufactured, okay, and then that will get added here. Okay, and what all things you can see. So all this part will get affected, and finally what is the purpose of the part will be lost. So the shaft, yeah, first thing is shaft will not sit in this. If it is very loose, then the functionality of the shaft will not happen. Okay, it's not even if it rotates, then there will be because of the this loose fitness. Okay, it's not going to fit at all. So it's complete failure, you can say. Got it, guys? Hope you got it. Okay, that's a one point where we have to take a lot of care, so that we can avoid mismatch of the dimensions throughout the part. Okay, if one part is master thing is good, then from there you carefully take the dimension with the same precision or the same tolerance is what is given to you, and that same tolerance, if it is plus or minus zero point 0.1, then that same 0.1 within zero point 0.1 you can measure, take one more dimension, so that you can get exact same dimension, or within the required tolerance. Within the required tolerance, you can get the dimension. Okay, guys, is that clear? समझ गया ना भाई? समझ गया ना भाई? हिंदी हिंदी बहुत लोगों को आता होगा.
Yes, sir.
हाँ सर.
Understood.
बहुत लोगों को आता होगा. ठीक है, तो उसमें भी बता देता हूँ. अगर इस होल का अगर जो भी डायमीटर है वो अगर हम इसको क्यों कंसिडर कर रहे हैं, क्योंकि द डायमीटर द डायमेंशन ऑफ दिस होल क्यों कंसिडर कर रहे हैं, क्योंकि इसको हम बहुत अच्छी तरह मैन्युफैक्चर करने जा रहे हैं. क्योंकि अगर मैन्युफैक्चर नहीं हुआ तो ये उसका फंक्शनैलिटी जो है वो फंक्शनैलिटी इधर काम नहीं करेगा. क्योंकि अगर छोटा हो गया होल तो क्या होगा, वो शाफ्ट आके इसके अंदर बैठेगा ही नहीं, तो फंक्शनैलिटी गॉन. बड़ा हो गया होल, क्या होगा, वो शाफ्ट आके इसके अंदर बैठेगा, मगर अगर वन मोर मोटर इज कनेक्टेड टू दैट एंड इट हैज टू रोटेट, देन वो कंप्लीटली फेल हो गया ना. उसका जो फंक्शनैलिटी जो है होगा ही नहीं. इसके वजह से वो टॉलरेंस हमको मैनेज करना पड़ेगा, मेंटेन करना पड़ेगा. तो उस पार्ट में हमको देखना पड़ेगा which part is maintained. Okay, which feature will be maintained. We have to maintain that tolerance in this feature. If we are maintaining that, then we have to consider that and as a origin, and from there if you take dimensions, सब कुछ भी दूसरे डायमेंशंस भी अफेक्ट नहीं होंगे. ठीक है, वो जो टॉलरेंस ज्यादा नहीं हो जाएगा, आपका लिमिट में रहेगा और आप उस पार्ट को प्रॉपरली मैन्युफैक्चर कर पाओगे. गॉट इट गाइस? ओके, थैंक यू वेरी मच.
Yes sir.
Okay, now this is very important thing. These are the important things you have to understand. And what next next we are going to do in the Catia, that is secondary. First thing is we need to understand the theory behind this. Unless you don't understand all these things, Catia में जाके करोगे क्या यार? कुछ नहीं करोगे, है ना? Catia में जस्ट ऐसे ऐसे करते रहोगे तो कुछ नहीं रहेगा. पहले हमको समझना पड़ेगा कौन सा पॉइंट है, कौन सा ओरिएंटेशन है, क्यों ले रहे हैं, क्या है बाबा इसके पीछे, वो सब समझना पड़ेगा. ठीक है, दैट इज वेरी इंपॉर्टेंट. So these are the basics, guys. We already have next level course also. Okay, that is next you can see that. Okay, basically you need to understand all these things. Okay, okay, let's quickly. और मॉडल करना तो बहुत इजी है यार भाई. अभी तक बहुत मॉडल कर लिया हमने, है ना? बहुत देख लिया आपने भी. अभी देखो, सिंपल. टेक दिस, वी डिसाइडेड. So once you have decided, just have a look at these dimensions and start doing it. You know commands also now. You people are smart and you people know commands, all the commands. Okay, what I'm using. So I know that, and you people are very hardworking. You people are doing that at home also. I'm proud of you guys. Okay, so let's start with this. Okay, I'll switch off this here. This is something. I cannot see the screen. Okay, I'll switch off this for a while. Okay guys, let's start with this. Always position sketch. Okay, okay, now let's make it side by side and do it fast हो जाएगा अपना काम. Okay guys, so ये रहा अपना front view. These are front view. Okay, okay, so if you look from this direction, what all things are visible here? Okay, let's start with this. So our center is this. As we decided, this is important center. Okay, important feature of the part. So we decided, so this origin is that part. Okay, simply I'm taking मुझे चाहिए सिंपल एक किधर है भाई? ये रह गया। So इसमें ये है क्या? So ये switch off कर लो यार, ये switch off कर लोगे ना, that will be very easy for you. Snap to point, switch it off. If you don't want grid also, you can switch it off. Okay, then you can do it easily. So simple. So I need this profile. So how to achieve that? Then we'll go here, and so now you're going to tell me the height of this part. Okay, let me drag it down. ये इधर बैठ गया ये, इसको नीचे खींचते हैं। ये जो पार्ट है इसको थोड़ा इधर कर लेते हैं, ठीक है। इसका difference we need to find out. Okay, that means our point is, origin point is this, and from this surface I want. Okay, what is the height of, मेरे को इधर से एक टॉप से इधर तक का डायमेंशन चाहिए, क्या है वो बताइए मेरे को। ये टॉप से चाहिए, इधर से
41 sir.
इधर तक कितना है डायमेंशन?
41 sir.
सॉरी
41 till the base sir.
41 ना? 41, let us see how you calculated. This is 21. Okay, 21 plus 21, isn't it? Fantastic. So up to here it is 41. Sure, ये 41 हो गया है. Okay, 41 हो गया. तो ये क्या करते हैं, टॉप वाला it should interfere with this. Okay, okay guys, now what is the width of this? What is the this 70 plus 14, 84, 84 plus
98, sir.
14, 90,
8.
98. Okay, simply take this as 98. Let's consider this as 98. So is this part, is this center at the mid of the part here?
No, sir.
No.
Sir, we have to take width as 42, sir.
Guys, sorry. Yes. So let me understand if this part is at the center or where it is for this profile. This axis, is this the center of this part? Do I need to make these two lines symmetrical to this? Yes or no?
Yes, sir.
Good. Because this, if you see here, this profile is exactly, this origin is exactly center of this, right? So we have to consider. So let's do how to do that. Symmetrical. Select this, and finally the final axis. And then let's go here and say symmetry. Okay. Now this profile is symmetrical. So my 98 mm. Okay. 98 mm maintained here. Okay. So you want to let's just carry on with this profile itself. Okay, So let's do this profile also. This 6 mm cutout here. Okay. So throughout we have this cutout, right? That's what we understand from this view. We have this cutout throughout the part. Okay. So let's create that also. And sorry, not this. Take a line here, which is a horizontal line. We are creating this. Okay. And this is 6 mm from here. So this should be 6 mm. Okay, so this is maintained. Okay, and I need two vertical lines here. So and the vertical line is 14 mm. Okay, 14 mm from this direction. Okay, take a line here and say from here to here it is 14 mm. Okay, 14 mm. Okay, good. And now I'm going to trim it. Simply trim it. Where are the things? Let's take this. And I don't want here. And my profile, if you see here, this has to go up to, what is the height of this? This is 20 mm. 20 mm height I need to maintain. Okay, let's have 20 mm here. Okay, this is 20 mm. Guys, are you following? Am I going speed? You want me to go slow? Okay, so this 20 mm I maintain for this. Okay, what is the height of this profile? This is 20 mm. Okay, I'll go slow. Okay, I'll go slow. 20 mm here, and then this line, and this line, I'm going to cut it so that we can use this option, trim option, so that we can have this profile here. I'm done with this. Okay, this profile, this corner is done. Okay, this cut is done, and then now I need a line, same line here. Okay, so instead of drawing it again, I can use mirror option. Okay, click on this, click on this. Okay, same line is generated here. Now I'm going to use trim option, and this horizontal line you can extend and just click on this. Okay, so this whole profile is completed. Okay, this the cut which we have here is completed. Have a look and let me know if you have any questions. Okay, and finally I'm going to cut this also. In between, if I click on this, let us see what it is saying. So this side it is cut. Now let me also trim it here. Okay, so again this is also 20 mm again. Okay, so this and this 20 mm, and we have this line here. So from 20 mm we have one horizontal line. Okay, this line should coincide with this, and now horizontal line till the end of this, and this extend this line and just close it. Okay, and what is this? Why it is 12 mm? How much it should be? It should be 14. Okay, if this is 14. Okay, okay, so now carefully we need to look at the dimensions. What dimensions we have given here? Very carefully we have to see. And what is the height of this? Is this 40 or 41? 41? Guys, what was the bottom from till here? What is the height of this from here to here? From here to here. This 20.
62, sir.
Plus 21, isn't it? From here to here, it is 20. This is next step, right? So from here to here, it is 21. That is 41. 41 plus 21. 62. Isn't it? Okay, so
So-
this is 62.
That one is 41 only.
Which one? Sorry.
Uh,
This surface is this surface. Okay.
yes, sir.
bottom
But origin, we are taking the midpoint of the circle.
Okay, so from origin you are saying, right?
Yeah.
Then minus this 21, right?
Yeah, yes, sir. 41.
Exactly. Then this is correct then. So this is 40, 41, right?
Yes, sir.
So here it is 41, and this surface we have to take here. Exactly. Okay. Got it. Okay, guys. Now we have completed this profile. Okay, this is important profile for us. As of now, we have completed this. Before going to next step, that means we will go to this. Okay, before going to this, just have a look at this. Dimensions we need to consider carefully, because finally in the drawing output you will be getting all these dimensions. Okay, you have to create a drawing like this where every dimension should match. Okay, if input is wrong, that means somewhere here, if we are giving wrong input, then finally we'll be getting all the wrong things. Okay, again it's kind of rework. Okay, to avoid the rework, it's always good to check twice or thrice in basic sketch itself, so that we can avoid or delete unwanted things. And so any doubt in this sketch, creation of this sketch? So this will be, you can delete this, this is not required. Okay, so compare with the front view of this. All dimensions maintained. Okay, this kind of quality check for you. Okay, so where this 20 mm is there, so here. Okay, and 41 mm, so 41 mm up to here, and then above that we have to do it now. Okay, so what else we can do it now? So up to here we have completed. Okay, the bottom profile is done, and now the this profile. Okay, this profile we have to complete. Now again, this is at the center, so let's consider a vertical line. So vertical line, if it is blue in color, that means vertical. This is vertical. So I'm just extended it till the profile. Okay, and what is the thickness for 14 mm? Okay, so let's say 7 mm here. Okay, and then say mirror 7 mm. Okay, this is done. And what is the height we need to maintain? From here 21 mm. Okay, we need to have a horizontal line which will be of 21 mm from this center. Okay, this is 21 mm. Now trim it, take, just double click the trim, you can double click and then start trimming it. Okay, this is done, this is done, and now this is also done. Okay, now we need This side line is gone, so let's mirror it. Okay, say mirror. Now what should be done? This and this, done. Okay, let's have a look at this. Okay. So guys, have a look at this. Compare this. Is this right? What we did? So till here we have checked. All the dimensions are okay. The undercut what we have given. Okay. This is also 6 mm maintained, and the top one which we have done is of thickness 14 mm, and it is at the center. Okay, that's the reason we have taken this thickness of this is 14 mm, so we have considered 7 mm on both sides. Okay, so for that, how to use mirror command, you saw that. Okay, any questions on that you want me to repeat, or is that okay? Okay guys, so now let us check how is your sketch. It is closed. Okay, and everything is fine, so we can use pad operation.
So,
Yes, please.
so what should we do when the line is of white